Hey guys, how's it going? It's Dilmer again, and welcome back to my channel. So first of all, I'm pretty excited about today's lesson because I'm actually gonna go through a lot of different topics around object-oriented programming. I am really passionate about this topic, and I hope by the end of this lesson you have a better understanding of why we use objects in programming in general, but also how we can actually use them in Unity when creating games. So the first thing that I wanna show you is I actually updated the README file in the GitHub repository that I shared with you guys in the previous video. I actually already committed this and submitted, so you should be able to see this description in the README file. So the first thing that I want you to know is that I actually have a playlist for all the videos that I'm gonna be, and the ones that I actually have covered already, and the ones that are upcoming. So make sure that you look at this playlist if you miss a previous video, or you're curious about what's already there, you need to revisit it. So then the next thing that I want to do is I want to start with some theory and actually talk about object-oriented programming and in a specific what a class is and why do we do these things in programming. So I want to basically read the description and then we can go into more theory. But basically a class is a user-defined blueprint or a prototype from which objects are created. Basically a class combines the fields and methods, member functions which define actions into a single unit. In C#, classes support the polymorphism, inheritance, and also provide the concept of derived classes and base classes. So what that really means is that basically a class is a placeholder for data, but we can't really represent it, in a way that it's just data. We want to represent things in the real world that are objects. For example, an object might be a person, an object might be, your cell phone that you're holding with you. Your cell phone has different attributes, it has different behavior, it has different properties, different information that it actually, can provide to you. So how do we interpret some of that information in C#? It's very important, and that's basically the concept of object-oriented programming, is that everything is encapsulated in object-oriented programming, meaning that if we have an object that is a cell phone, that object has its own set of data, it has its own behavior, it has its own properties that you can get out of it. Also, the cell phone needs to communicate with other components of itself. So the cell phone also has an operating system that it needs to communicate with. So the operating system itself can be another object on itself that has different behavior, has different properties. So what I'm gonna go through next is I'm actually gonna show you how a class is structured and explain to you the different syntax that goes into creating a class. I'm also going to go through and actually create a few examples using classes, inheritance, and encapsulation. So in another example, we can think of a class as a human. So if we have a class that is a human, a player can also be a human. So that's what I'm talking about. Inheritance is that what I'm going to be doing is we're actually going to be creating a class called human, and then we're going to derive from that class another class called player. And the reason why we do this thing is that we don't want to create a completely new class just for the player. We want to inherit some of the different attributes and fields that the human has. So if a human has a set of eyes, a player might have a set of eyes. If a human has a left hand, then the player also has a left hand. So those are the kind of things that I want to go over. I'm going to create a monster that is basically going to inherit from the human. A monster might only have a left hand, it might not have a right hand. So those are things that we can actually override in the monster class. And then another thing that I'm going to use is I'm actually going to create a score class, and I'm going to use that for encapsulation. I want to also add some things in the score that I really don't want specific classes to have that information. I might not want the player to to basically change the score itself. I want the game to change the score. So those are some things that we can basically, protect on the score class for, so the player can really access that information directly. Another class can access it directly. So, and then the other thing that I didn't mention here is I want to talk about composition, and composition is basically, if we want to have a class as a property of another class, that we're basically going to have a player is going to have a score. So I want to use composition to basically provide that information for the player. So let's actually go into some code. I know that I talk a lot about theory, but I think this is a topic that I won't be able to cover in an hour. But if you hang up with me, I'm going to walk you through some examples, and then by the end of this lesson, you should have more information about why do you need to use object-oriented programming. So the next thing that I'm going to do is let's actually jump into Unity, and like I've been doing in all the videos, I'm actually going to create a new video, and it's actually going to be a game object, and we're going to right click on it and then create an empty, and this is going to be video 4. And just like I did on the previous lesson, I'm going to create a script called video 4 too, and we're going to place it under scripts. And the next thing that I'm going to do is I'm actually going to go to video 4, add component, and then we'll just assign it the new script. And looks like it hasn't shown yet. Let's just save it just to make sure. Okay, let's go back into video 4, add component. Give it a second. Looks like it's actually compiling. And there we go. Okay, and let's just assign the video 4. Then the next thing, let's actually go into and open up the video 4 script so that we can open Visual Studio 2017. You can also do this in Visual Studio Code if you prefer. So let's actually, I'm gonna start with a human class, and as I create a human class, we're gonna be basically describing the structure of a class. So if we go back into, let's go back into Visual Studio and into our video 4. So the other thing that I want to do is, this is actually a mono behavior. So I actually want to create just a class that can hold the human information. So let's go back into Unity, and inside of scripts, I'm actually going to create a new folder, and let's call this new folder, we can call them objects or just classes, just for the for the purposes of this video. And then inside of classes, let's create a new, right click on it, create a new script, and this is actually going to be called human. And let's go into human, double click on it, and that should open up here in just a second. Let's give it, oh, there we go. Okay, so let's double click on human. I don't really want to so normally if you create a C# script from Unity, it's gonna by default inherit from mono behavior. I don't want to inherit from mono behavior. So let's actually just start with something as simple as a public class. So normally the syntax of a class that is gonna be used for, for maybe the video 4 needs to access a human. So that's what the accessor is gonna allow you to do. So the structure is you're gonna start with the accessor. So the accessor means that public means that somebody else in the code can actually access this class. If I were to do that, I'm not gonna, nobody else is gonna be able to access it, because by default, if you don't put an accessor on it, it's actually gonna be private. And this is gonna make more sense as we get into it. So the structure of a class is basically what you're seeing right now. You have to specify what the accessor is, which in this case is public, and then you follow that with the word class, and then the name of your class. So this can actually be named monster if I wanted to call it monster. I could call this, basically anything that you want. It has to represent the object or the class that you want to create. So in this case, we're going to be creating a human class. So the next thing that you need to think about is actually what different attributes or fields the human is going to have. So every human has a name for the most part. So you want to specify that this person is going to have, this human is going to have a name. So I might specify a field called public string, and then we can call this one first name. We could also give it a last name. We know that every human has an age, so we have to specify basically public and the type that we want to specify. So if we're going to do age, we're going to do integer and then age. So what you're seeing right now is I'm actually creating an object that has different fields associated with it. So if you look at the accessor that I have right now, it's set to public. You can actually set it to private if you wanted to, or you can set it to protected. So for these, in this case, I'm actually going to set him to private instead of public, and I'll show you why I'm going to do that in just a second. So the other things that the human might have is it also has, we can say that a human has a right hand. So we can add a property say has right hand, and we can initialize it to true because every human for the most part has the right hand. And then we can say has left hand. We can say that this human has legs, and so on. Basically we can add more attributes to this person, so, or human. So the other thing that a class also has is what's called a constructor. So let me show you what a constructor is. And by default, if you don't create a constructor, it automatically, C#, the runtime actually is going to create it for you. So this is the syntax of the constructor. Normally you start with the, well actually all the time you start with the word public, and then the name of your class has to match the name of your constructor. Then there's something else called, basically if you want to override the constructor with different parameters, you can also do public human and say that we want to, for this one, we want to pass in all the parameters that we have right above. So we can say, okay, we want to create a human with a first name, with a last name, with an age. And in this case, I don't want to specify if it has a right hand or left hand. We're just going to assume every human has that set. And then in this case, I'm going to use the word this. The word this designates that I want to access anything in this, basically every field that I have in here, or every method is how I can access attributes, methods, and any information that is in the scope of this class. So if I say this first name is actually referring to this first name right here, or and it's not the same as the first name on the argument. There is different people that do basically different variables. If you want to use a different syntax, I've seen a lot of programmers use underscore for private variables. You're welcome to do that, and in that case, you don't have to specify the word this. I like using the word this, so let's actually use it so that you understand why you would use it. Then if you do this, the last name, we can say last name, and then this, the age, equal age. So why would I create a constructor? And then why would I create a constructor without any parameters? So not every time you create because we're gonna have to create this object, I don't want to have to specify first name, last name, and age in every object that I create. I might want to specify, I just want to create an object of human, and I want all these variables to be basically their default values. Like a string is going to have, I believe, a default value of an empty string, this one as well. And then the same thing with age. Age is going to have a default value of 0, and then has right hand and has left hand is going to have a default value of true, because that's what I set it to be as default. So the other thing that you can do here is if you're unsure of what the default values are going to be, you can also set them, to double quotes by default. You can also specify, 0 by default. You might want to, give somebody a default age or a default first name. or maybe just a Boolean value like I did in here, that I am assuming that every human has a right hand, and that every human has a left hand. So how do we go actually about using something like this, and how do I access the first name? How do I access the last name? So let's actually jump into video 4 and let's actually create an object of type human. So I now have what's called a blueprint of this class of human, but I actually haven't actually created an instance of it. So if I go to video 4, and I'm actually going to remove the update, and we're going to work in the start method. So now that I created that class, how do I actually use it? So the way that you use it is you're basically going to use the name of the class at the beginning, which you name it human, and then followed by a variable. So I'm just going to call it human. Let's say that we create multiple human. This is going to be human1, and then you do equal, and then you got to use the keyword new, which is going to designate that you want to create a new human, and then followed by the class name, and then parentheses. So it's normally, if I do some pseudocode here, it's going to be the class name followed by the variable name equal the keyword new followed by the class name, and then parentheses, which is actually calling the constructor. So if you remember on the constructor, I actually had a constructor that had parameters. So that's what's called the constructor. I overloaded the constructor. So if I hit up arrow, I see that there's a constructor that basically takes a first name. There's also one that takes a last name, and I also have an age. So in this case, I'm not going to basically passing anything. And in here, we're just going to say debug.log. And then we're just going to debug basically the variable human1 to see what we get back. And what I'm going to do here is I actually want to attach the debugger because I want to show you what's happening behind the scenes when this object gets created. So I'm just going to basically add a breakpoint on this line and then attach to the Unity debugger. Okay, let's just give it a second until it compiles and attaches to the running process. Excellent. So now let's go back into Unity. Oh, and I actually haven't associated these. Let me go back into, actually stop the game and go back into here. I actually already did it. Okay, perfect. Let's do this one more time. Attach to Unity. Okay, go back into Unity. And I'm actually going to hit play so that we get the mono behavior attached to video 4. It's gonna basically get instantiated when the start method gets called. So the start method gets called, and we can step over, and we can look at the human itself and look at the variables. We can see that we have the variables set because those are the default values that we gave it, but we don't really have anything, we haven't really designated a first name or a last name. So if we hit continue and we go back into Unity, into the console, we can see that we are seeing a human, but that's really it. We're not seeing any information whatsoever. So it's actually, hit play one more time. I'm actually going to disable video 1 through 3 so we don't see everything else for the other videos. Okay, let's go back into, this time around, actually let's go back and actually hit play one more time. All right, and let's go back into, Visual Studio, and I'm gonna step into this time. So if I step into it, it's actually going to call all the fields. So I'm gonna go over those and set them, perfect. And it's actually gonna call the constructor, the empty constructor, because I didn't call the one that has parameters. And we step over, so that's basically the life cycle of that object. Let's go back here. I'm actually going to change this really quick. Okay, let's go back into, so now I have a human, but it doesn't have any data. So what I'm gonna do here is let's actually stop the debugger. So what if we wanted to set some data, because I already have default values. So we can say we can actually do that notation on that variable, and I can say, you know, human1. Oh wait, but I don't have access to anything. So, and that's the next thing that I'm going to explain to you. Why don't I have access to any of the fields? So what if I use the other override? So let's remove the breakpoint so you can see. So what if I wanted to set the first name so I can actually call the second constructor? So on this one, I'm going to say, okay, the first name is John. We can say comma, Doe. Let's say that John Doe has 25 years old. Let's go back into Unity and hit play. And we're still seeing the human. We don't see, oh, hang on, let's just, yeah, we're still seeing the human. We're not seeing any data. The reason why we're not seeing any data is because I'm actually just calling human1. I'm not calling, you know, any of the variables that it has. So we can do, there's something really cool about C# that you can do. You can actually override the toString method. So we can do an override on this class, and we can override the toString. And the way that it works is like everything inherits from object, and the toString is a method that is available for every object in C#. So we can do something like, you know, instead of calling just base toString, which is actually just calling human, basically the object. If you look at it and you hover over it, system.object. So if we want to change this, we can say, you know, I want to return a combination of, you know, the first name, and then we can do plus symbols and quotes and a space to separate first name and last name. We can do last name, and we can actually print the H at the end. So now if we go back into Unity, actually let's go back into video 4, and I actually need to do, I believe I need to do a toString. We'll try it without it and with it just to make sure. And we can hit play. And we should see the H, the first name, last name, and the H. And that's basically what we did. Perfect. So we can actually remove toString just to see what happens. And go back into here, hit play, and I don't need to open Chrome. I'm actually going to close it. Perfect. And let's just let it compile. And actually works without the toString, because I think what debug log does on the object is actually making it so that toString gets, you know, gets called behind the scenes. So let's actually put a breakpoint here attached to the Unity project, and I want to walk you through what it's doing, and then hit play. I learned a lot by debugging, so as I debug through creating a class, I think it's going to give you a lot more information on how a class is getting created. So right now the start method got called, and I'm passing different parameters. So if we step into that, it's still gonna be setting all these different variables. And actually, you can notice that it didn't call the default constructor. It actually called the one that we overloaded. And we can see that first name is John, last name is Doe, and the H is 25. Perfect. And we can see that it's setting all the variables, which these are called fields. So it's setting all my field variables. Perfect. All right, so now let's go down and actually continue. And I'm gonna hit play one more time. Okay, perfect. And I'm gonna actually stop the debugger. Okay, so that's great. We can call the toString. We have different field variables, but I don't have access to anything on the other side. So if I go back to human, actually video 4, it'll be nice if I had access to more information in here. I didn't really want to, you know, have that be controlled by the toString method. So that's how we can use, that's why there, you know, we can use properties. I could actually go in and you know change this to public if I wanted to. And if I go back to video 4, and now I'm going to have access to that variable directly, but I don't really want to do that because I don't want, you know, other parts of the code to be able to change the basically a human's first name without, you know, the right protection. So that's basically one of the big concepts of object-oriented programming. It's the concept of encapsulation. You don't want to have, you know, everybody talking to everybody being able to write to a specific class. I want to have some protection within, you know, within this object that only certain classes can actually talk to it. So what I'm going to do instead is I'm actually going to expose it using a property, but I'm not going to allow to, you know, other outside classes to be able to set it. So how do I do that? I can actually use a property, and you can create a property by just designating an accessor, which in this case is going to be public. Those properties are going to be public for the most part. And then I'm going to actually call it first name with capital letters this time so that I know that it's a property. And then you can see that I didn't put parentheses in here because properties actually are not, that's not the right syntax. The syntax is that you put curly braces right after the variable name. So it's going to be public string and then the name of the property. And then inside you're going to put a getter. So this is going to be a getter and return first name. So what are we doing here? So what we're doing here is I'm actually going to allow somebody from the outside, another class from the outside, to be able to get the value of first name. So now I can actually change this back to private. And perfect. And if we go back to video 4 and I go into and select human, we can see that we have a different icon for properties. So those are actually designated as properties, where these ones are methods. So you can kind of see that it has a little cube versus a range. Okay, so now if I do that and I go back into Unity and hit play, you will see that now I should get John in the results. And we got John, perfect. So what if I wanted the last name as well? So we can basically just copy this code and then change this to last name and then change this to last name. And we can actually do the same thing that we did in here. We can say human1 the first name, or we can say human1 that last name. And we can do the same thing with H if we wanted to, and basically any other properties that are here. So the other thing that we can do with properties that I think is really cool is we can create a new property that is based on basically multiple fields. So we can say, okay, I want to, you know, I may want to know the first name and last name, but I really don't want people to access them directly. I want to know the full name. So you can say public string full name. And then with this property, we can say get, and then we can return, you know, we might want it, maybe we want last name first, plus, and then we can add space here, and then format it, first name. So now when we go into video 4, we can say, you know what, I don't want first name and last name separated. I only want, let's actually leave this here so that you have it for information when I check it in. So in this case, I may want to know, you know, I may want to know the full name. Now if we go back into Unity and you hit play, we should see Dojon, because that is basically what we put in the full name. Perfect. Okay, let's go back into Visual Studio and let's go back into human again. Excellent. So another thing that you can do in a class, you can also create regions. In this case, I'm going to create a region for, you know, properties. And you can do this with any type of code in C#. I'm going to do this so that we can get organized. And what that does is actually adds a minus and plus symbol so that I can expand and collapse. I'm also going to do a region here so that you know that these are fields. And region. And we're going to basically collapse those. And this is going to be region constructors. And we're going to end it here. And region. And we're going to do the same thing with method overrides. Region, we can say method overrides. And the next thing that I want to show you is how to actually create a method that you can access from a class. So right now I'm going to expand fields so that we know which data we're dealing with. So I may want a method that basically tells me if the last name was populated or the first name was populated, or perhaps if, let's say that we want to add a validation that says, okay, I have to have first name and last name before this human can be, a valid human. So we can create a method for that. So I'm actually going to do a new region, and this is going to be methods. So again, these regions are not required. This is just for me to organize the class so that you know what I'm talking about. You don't really need it if you're going to create a class. So in here, I'm going to create a method. So the methods can also have accessors. And if you create a method without an accessor, that is actually going to be a private method, which means that only this class is going to have access to it. So in this case, I want to make it public. And I want to return whether the first name and last name, I want those two to be basically populated before this human is valid. So I can say I'm going to return a bool, and then I'm just going to create a isValid method that returns a boolean. Perfect. So one thing that I can do is I can add a logical expression here with the if statement, and I can say, a string is null or empty, first name. So as long as this human, the first name is not null or empty, and actually, and this human, so we can actually copy this entire thing. So what I'm going to do is if it's null or empty, or let's actually do an or, because if the first name is null or empty, or the last name is null or empty, I want this to be invalid. So we're going to return, so this is going to be false. Otherwise, we can return true. So we're saying if the first name wasn't specified, I'm just going to say this is invalid because I'm returning false, and the same thing with the last name. Otherwise, it's going to be a valid human. So how do we actually test it? We can actually go back to video 4, and I want to know if this human is valid. So we can say, here I'm actually going to add some comments too, and we can say testing properties, and we can actually just print everything so that we have it for record. And then the next thing that I'm going to do is I'm going to say testing methods, and then I want to know if this human is valid, so I can just say is valid followed by the parentheses because we're actually executing that method. And I want to say, put basically some information in here, and we can say, is this human valid? I put a question mark, followed by the results of this valid, which is going to be a boolean. So let's actually go back into Unity, and then hit play one more time. And let's give it a second. Okay, so we can see John Doe John, what's the full name, and then is this human valid? And it is valid because we specify a first name and a last name. So what if we don't specify, say we don't specify the last name? So we can actually don't even specify it, and we can go back into Unity, hit play, and we expect to see a false in this line, and we got a false because we didn't specify though as a last name or anything as a last name. Okay, perfect. So I'm actually just gonna put though one more time in there. So the other thing that I want to know, let's say that this person, we want to know if this human is over 18. So we can actually create another method to do that. And I'm actually just gonna duplicate is valid, and then we can say we can just say it's an adult. And we can, instead of doing this logic here, we can just say return. We know that we have the age, so we can just say age. You can actually use this if you wanted to. In this case, I don't need these because there's nothing within the context that is called age. So I can actually just use age is greater than or equal to, let's say that our requirement is 18. For the most part, that's what, when a person becomes an adult. So if we're greater than 18, then this person is an adult. Otherwise, it's gonna be false. Actually, let's go back into video 4, and we can add another question here. Is this human an adult? And we can say, instead of is valid, we can say is an adult. Perfect. So now if we go back into Unity, hit play, and give it a second. So we should spec a true on the human is valid, and also a true on the adult, because the age that we specified was 25. So if we specify, let's say this human was only 15, and we go back into Unity and hit play, we should expect to see a false on the last line. So yep, it looks like that part is working. Awesome. So we basically know how to create an object. We know how to create properties. We also know how to create methods. So let's actually create a method that returns something other than just a Boolean. So let's go back into the human, and I want to return. Let's look at this. Let's say that I wanted to know the length of the first and last name. So we could do, return full name length, or we can say full name size. Maybe we have some validation that we needed to do on the full name. We might not want to, if it's 2 digits, then that's just too low. So we can say, I want to know what the first name, that length, plus last name, that length. So that's going to give us the length in characters of how many characters I have in first name, plus how many characters I have in my last name. And then I'm returning an integer because these are integers, and I'm basically summing integers. So let's go back to video 4. And then we can say another question. We can say, instead of doing is, let's do what is the size of the full name. I think length is more appropriate for this in characters of the full name. Perfect. And instead of calling is an adult, we're gonna call the other method, which is full name size. Perfect. Okay, so now let's go back into Unity, and then hit play, and we should see the length in the last line. And we got a 7 because John is 4, Doe is 3, so that is length of 7. Perfect. Okay, so now let's go back into our README so that we basically go through the next steps. So I basically show you the structure of a class. We can actually go back and just look at it one more time. So I explained to you that, that these are fields, basically the syntax is public class and then the name of the class. Then you have your field variables. Then after that you can have, properties. You can have your constructors, which I show you how to overload. Also, if you don't specify a default constructor, the system is going to create one for you. So there's really no need to do it. I'm just doing it for demonstration purposes. And then this is the one that we overrode. Then the next thing that we did is I actually show you how to override the toString method to return the first line name, last name, and age. And the other thing that I show you how to do is I show you how to create methods, and I show you how to create two different types. One was a Boolean and the other one was an integer. The other thing that I didn't show you how to do is actually create a method that was only available by this class, and it's really not as complicated. All you need to do is just basically change the accessor. So I may want to have something like, I may want to have a method that is private. We can say Boolean and is full name correct as an example. And if I do private, let's say that I return false, and this is just for demonstration purposes. If I do that, if I set it as private and I go back to video 4 and I try to do human one that, I'm not going to have access to that method, and you can see that the method is not actually showing. So the way that I would have access to is by anything that is in this class. So I may want to, maybe call that from here, and you notice that I have access, and it actually has a lock. It has the symbol of a cube, which is, of a method, but it also has a lock, which means that only this class has access to that method. So that's a big concept of encapsulation, that I'm actually abstracting this out, and I'm not letting video 4, access to that. So I'm actually going to delete it, remove it, perfect. So that's basically everything about, creating a class. So let's actually go back into our README. So the next thing that I want to talk about is actually inheritance, and why do we do inheritance in object-oriented programming. The reason for that, and let's say that we didn't know that inheritance existed. Yeah, we could actually copy the human and then just name it player, and then add more attributes that are specific to the player, like a score, like other things like that. But that's really a lot of duplication and overhead. So that's why we have inheritance in object-oriented programming, is that we can inherit the fields, the attributes that the human has, and then just basically add to the player. So let's actually do that. So let's actually create another class. I'm going to go back into Unity, and I'm going to go back into our project. So I'm actually I think I lost that view. And I'm going to right click in here. So it's 11:50 p.m. and I'm losing my head, so bear with me here. And I'm looking for my project window. For some reason it went away. Okay, let's actually go back into default layout. It's gonna reset everything. Okay, perfect, we have our project. Okay, so under classes, I'm going to create a new class. And this class is actually gonna be called player. I'm actually gonna duplicate it, and I'm gonna call it, this other one I'm gonna call monster. And if you remember, we had another one called score, so let's actually create that one as well. And we're gonna fix some of these errors in a minute. And then score, perfect. So let's go back into Visual Studio, and let's just make sure that everything is named correctly. So again, I'm not gonna inherit from mono behavior. I'm actually gonna delete all that. I'm gonna do the same thing with the player. And also with with the score. So let's go into the score, delete that, and actually looks like this got named incorrectly because I duplicated from player. Okay, so we have score, we have player, and we have monster. So monster, let's rename this to monster. Okay, perfect. So the one that I want to create is I want to create a player. So how inheritance work is you have to use the column which goes after the class name and then the class that you want to inherit from. So in this case, I want to inherit from the human. So that's really all you need to do to create a class that inherits from another object. So if we go back and let's go back into video 4. Let's say that I want to create, so I'm gonna put a comment in here, creating a human. And then in this other area, we're gonna be creating a player. Perfect. So a few spaces here. Awesome. So now all I gotta do is basically specify, okay, I want to create a player. There's gonna be player 1, same syntax as above. And so, but right now I don't have access to, setting the player name through the constructor, but I do have access to, if I go player 1, I have access to first name, full name. I have access to basically all the methods and properties and fields that I had access in the human. The reason for that is because I'm using inheritance. I'm inheriting from what I have on the human. So if I go back to player, I don't have anything here declared. I'm only inheriting from human, so human has those attributes. Therefore, player it's gonna get them. So in fact, I can actually go back in here, and I could say, okay, player 1. It's gonna have a first name of John. Let's actually use Steve this time. And I want player 1 last name, and it's gonna be maybe Steve Toner. Excellent. So, but if you notice, I don't have access to setting these variables, and the reason for that is because this is only a getter. I didn't allow anybody from the outside to set those variables. So how do we fix that? So if we go back into a player, we can actually just call the constructor. We can do public and then player, and then we could specify everything in here, or we could actually do, let's do this. So there's two ways that we can do this. We can do base and call the base here and pass in all the different variables, or we can just do that base. I actually think it's, the syntax is like this. So we're gonna need a first name, we're gonna need a last name. So we're going to be passing in first name, a string that last name, and then integer h, and we're gonna pass it into base. So we're gonna be passing in first name, last name, and h. Excellent. So what is this thing that I'm doing right now? This is basically what it's doing is actually calling base, the base constructor, and passing the variables that I'm passing into the player constructor. So if I go back into video 4, now I can actually pass in a first name, last name, and age, because I told the player that I wanted a new constructor, and that constructor is passing the information back to the parent class, which in this case is human. So I can say, okay, this is gonna be Steve, this is gonna be Toner, and let's say that the age of this person is 25. And I'm actually gonna copy all these different properties here and change this variable to be player 1. And so we're creating a human, and then we're creating a player. So let's actually here do debug.log, and we can say creating a human, so that we know when we go into Unity, where we are in the process, and then this is going to be creating a player. Let's move it right beneath the comment. Perfect. And then testing properties. Now let's go into Unity and let it recompile everything. Okay, looks like, okay, perfect. Now let's actually hit play. And now go into the console. And we can see everything that it did. So we're creating a human just like we were before, and then we're creating a player, and the player name is Steve Toner, and then Toner Steve for the full name. So let's go back into Visual Studio. So now we have a player that has basically a human, and it inherits from human, and that's the syntax that you use. But let's say that you wanted to, expose another property in another attribute that the human didn't need to have. So let's say that this is a player for an Xbox, a platform. So maybe this person has a Xbox Live ID. So I may want to specify, that property as well. So what I'm actually going to do here is I'm just going to do a private and a string, and this is going to be Xbox One Live ID, for instance. And then the other thing that I'm going to do is just create so there's another cool thing that you can do in Visual Studio. You can actually right click in here, you can go into quick actions, and you can do encapsulate field. And what that's going to do is actually going to create a property for you automatically. This uses a little bit of a different syntax. This is called a lambda. And that's the reason why I don't use this as much, but I just wanted to show you that was available. Or you can do it manually just like I did before. So you can do public string Xbox One Live ID. And in this case, I'm going to say, I do want a getter. And in the getter, I'm just going to do return Xbox One ID. Perfect. But I don't want to allow people to set these from the outside. I want the player to set it itself when it's getting created. So what I'm actually going to do is I'm actually going to pass in a string in the constructor for the Xbox One Live ID. And in the body of the constructor, we can say this Xbox One Live ID equal to Xbox One Live ID. Perfect. Now let's go back into video 4, and this is complaining because we added a new parameter. So let's say that the Xbox Live ID for Steve Toner was Steve Toner at xbox.com, for instance. So now if we go back in here and we actually add that property as well, which we should have because we added a getter, and now we can go back into Unity. And we can hit play and give it a second. Excellent. And we can see that, we created a human right above it, and we also exposed a new property that just the player needed to have, but the human didn't need to have. So let's go back in here. Excellent. So the other thing that I want to talk about is composition, and composition is one cool thing that you can do with object-oriented programming, because as of right now I only show you how to add fields and attributes and data, but I didn't show you how you can actually have a class within a class. So let's say that I wanted the player to have a score. So if you remember, I actually added a score value. So let's go into the score class and add a property called, so I'm actually going to add a field, and this field is going to be, I may want a score to be, let's say that this score can be a decimal number, and because I want it to be 1.5 or 200.50, and this can be just the value of the score. And then I'm going to add let's actually just do the automatic way. Even though it's not the same syntax, just for simplicity, that it's available and you can use it as well. Perfect. So that's basically all I did. Is on the score I added a value, and we have value 1. Oh, and this is actually called, let's actually call this one value with lowercase, and then this one is gonna be uppercase. And I'm gonna do perfect. And value wasn't a good name because value is a key. let's actually do points then. And lowercase. And this one is gonna be, let's delete it and then recreate it, quick actions, and then points. Perfect. Okay, so that's basically all I'm gonna do in the score. And in the player class, what I'm gonna do is I'm actually gonna add what's called composition, and this is gonna be a score. And we're gonna use the class and then a score. So what I want to do is I also want to instantiate that when a player gets created, I want a score to be created, even if it's 0. Perfect. So I want to, if the player increments a score, I want this score class to, keep track of that. So what I can do is I want to add a new method. I'm gonna add a new method to the player, which is gonna be of type, let's actually add it, actually return the score as we get it updated. And the score is actually gonna do, so let's call it get score, because this is private, nobody's gonna have access to it from the outside. So we can just say get return score. So this is going to get us our score. We can actually use a property here that returns a score. In this case, we can just use a method. That's completely fine. Or we can do another one that it says that is basically going to be a void, and this is going to be set score. And in this time, I'm going to just basically pass in a decimal and then new score. And then I'm just going to say a score that points. I'm just going to add to the score, new score. Because this is a score that we're going to be adding to. It's cumulative. Okay, perfect. So in this case, it's probably better if we call it increment a score. Perfect. And I think that's all. Yeah, that's really all I needed. And let's go back into player. Perfect. Let's go into video 4 and do a few things too. Let's say that this player kill a monster. Player kill monster. So because he killed the monster, we're gonna add, let's say, 100 points to this score. So what I'm gonna do is I'm actually gonna do player 1. And then we had the score, increment score, and I'm going to increment it by 100. And then the next thing that I'm going to do is just going to do debug.log. We have a player, oops, not the class, the variable, player 1, get score. And I just want to know the new score, which is going to be points. And I'm going to actually add some messaging here. So new score, new player score is perfect. And then let's say that the player just killed a few more monsters, maybe 3 more, and we print the score one more time. So we should see, 100 for the score right here, and then 300 more, which is 400 at the end. So let's go back into Unity and actually hit play. And give it a second. Okay, perfect. And let's see. So we should see. Okay, perfect. And that's correct. So we see the new player score is 100, and then we added, because we killed 3 more monsters, we got a total of 400. So that's all working. Perfect. So if we go back into what we did, so we have a human like I was showing you. We also have a player, And I show you how to use composition by, incorporating a different class into the player. I also show you how to override the constructor and call the base constructor on the human. Then the next thing that I want to show you is how we can use polymorphism to get, to go from one type to another. So what I'm going to do is actually, so we have a human here. We also have the player that inherits from human. So on the monster, I'm going to do the same thing. I'm actually going to inherit from human. But let's see, but this monster, let's say this monster doesn't have, it only has one hand. So we can do public monster and the constructor. And we can actually override the, if we do this, and then I think I did, let's see, let me go back into human and just to remember. Oh, perfect. So has right hand. Okay, so I go back into monster, and then call it false. So if you notice, I don't have access to has right hand, and the reason for that is because this is private. This is only gonna be available through, through the human class. So the other thing that we can do is we can actually make this protected. And that's going to allow us other classes that are using human to be able to access it. So we can actually go into monster, and now we have access to, and let's actually go into human. Okay, perfect. So monster is not going to have a right hand, but it is going to have a left hand. So that's what I set it to false in here. Perfect. And then let's see, I don't want to do, let's not call into base because I did that on the other example. So let's go into our player 4, video 4, and now what I'm going to do is I'm going to create a monster. And this monster doesn't really need to have, we're not going to give it a name, it's just going to be a monster. And so in this case, it's going to do monster equal new monster. And we can do the log, and then monster has a left hand, and then we can basically print the, let's see, hand. And I don't have access to those either because the human basically didn't have properties that can allow us to access that. So what I'm going to do here is on the method override, let's actually just add a few more values. So I'm going to say, this monster, let's see, let's just do has left hand, and we can left hand. And we can do the same thing with right hand. Perfect. And plus right hand. That's perfect. So we can see some of that information. So let's go back into video 4, and I'm just gonna do, so instead of doing that, let's just see monster hands. I'll just do monster information because I'm printing more information than just the hands. Okay, now so let's jump back into Unity and actually go through polymorphism and why do we use polymorphism in the first place. So if we go back into video 4, and if you remember, I have, I actually inherit the player from the human and also the player from, the monster from the human. So what if I wanted to convert, a monster to a human? And the reason that I wanted to do that is so that that that's actually possible. Let's say that, for whatever reason, a human converted to a monster, and then it loses its power, so now it went back to a human. So that's how it will apply in games. So we can actually do, something really cool that we can do is we can actually do human, and then we can say from monster to human. We can actually convert this out, and the way that you convert it is you can use casting. So I'm going to cast it to a human, and the thing that I'm going to cast is a monster. So now if I go back here, I'm actually just going to print this information. And monster, let's see, human information from monster. And we actually have to use the variable that we cast to. Perfect. And we can actually go back into Unity, hit play. And let's see. I'm expecting to see the information for perfect. So you can see it's still, let's see, human information. I'm still getting information back because I'm actually casting down to a human, but I still have that information in there. I still have, a left hand equal to true and the right hand equal to false. So let's actually add another component. So if we go back to, let's say, player 1, I wanted to convert player 1 to a human. So if we go back here, we can say, I want to use a human. Let's actually move it, do it right here, from player to human. And we can actually do casting again. So we're going to do a human to, and then in this case was going to be player 1 that we wanted to convert. I'm going to copy all of this information, and we can say human information from player. And we can copy variable, go back into Unity, hit play. And let's just give it one more second. And looks like that works. Because we're actually converting the player to a human. We still retain all the information that we had. And the reason for that is because we're using inheritance and we're able to use polymorphism to convert, from one type to another. So what happens if I wanted to go the other way? If I wanted to, let's say that, let's actually go back. And let's say that I wanted to convert, let's say that I had a human, but I wanted to convert that to a player. So we did that on the human one. So if we go and say, okay, I want to create a player from, so we can say from a human to a player. And then we're going to do the same thing. We're going to do casting. And in this case, I'm going to convert it to a player. And this is going to be human 1. And I know that human 1 didn't have a score because, it was a human and now it became a player. But what I can do is I can say, okay, from a human to a player, now I want to give it an Xbox ID. Okay, so what if we wanted to go the other way around? Let's say that we wanted to go from a human to a player. So what we can do is we can actually start with, the type that we want to convert to. And we can give it a variable, so we can say from a human to a player. And I'm going to convert this, use my casting, and I'm going to use human 1. And the cool thing with this is, a human or a person might become a player. Therefore, this person is gonna get, you know, an Xbox One Live ID. And if you notice, I don't have access to that directly, but that's okay. We can go into the player and we can actually add a setter. So I'm going to say public string set Xbox One Live ID, and then we can just take in the new ID. This is the Xbox One Live ID. It's going to equal to new ID. Perfect. And oh, this actually didn't need to return anything, just void. Now if we go back into video 4, we can just call our method and we can say, you know, the new ID of this human. Let's say that we wanted to automatically set this, so we can say from human to player first name plus from human to player last name. And let's say that we wanted to append add xbox.com, for instance. And let's actually move these down so that you can see what I'm doing. So what I'm doing is I'm converting a human to a player, and then by using polymorphism, and then because I know that this person is going to become a player, I want to give it Xbox One Live ID automatically based on their first name and last name. And of course, you wouldn't want to do this in production. You wanted to add some validation and allow them to create a user. This is just for demonstration purposes. Okay, so now the next thing that I'm going to do is I'm actually going to display some other information. So I can say player information from human, and we can copy this variable. And excellent. So let's go into Unity. Hit play. And looks like we had an issue with casting. Specified cast is now valid on 54. So I think what's happening is it's not allowing us to go the other way, because a human doesn't really know anything about a player. So if I go back into human, I know that a human, you know, I know that a human is a human, but it doesn't really have any relationship to a player. So if you look at the player, we can see that the player, you know, takes some of this information and it inherits from base. So that's what I can go from, basically from a human to a player. So how would I actually go about doing something like this to, you know, to be able to convert the human that I have to a player? So let's look at the player class for just a second. So one thing that I can do is I can actually create a new player and then passing the information from, you know, from one class to another. So I could actually go in and say I could create a new player, and then I can say, okay, human 1, and then, you know, my first name, human 1 that my last name, and then human 1 that my age. Which in this case, and I haven't exposed the age, so let's go into human, and I'm going to add a getter and setter for age. So I'm going to go into my properties, and let's go in here and say public int age get and set. And let's actually do it like we did below so that you don't get confused. So I'll just do get and then return age, and we don't need a setter, so that's perfect. Let's go back into video 4, and then we can do human 1 that age, and then we can also give it the Xbox One ID just right from here without having to, to create another method on the player class that sets it. So we could actually just copy the contents of what we just created, paste it, and delete that other method. And perfect. I think I have, and this is actually going to be human1 and human1. Perfect. So what I'm doing is I'm creating a human, I'm creating a player from the human, so human first name, last name, age, and then the Xbox One ID. So that's what I wanted to show you. I wanted to show you that you could go, if you're casting, you can cast down. So if I'm grabbing, for instance, a monster that inherits from a human, I can actually cast down, but I cannot cast, the other way around. So in this case, I use the player, and I already had a human created. So to go from a human to a player, all I needed to do is basically pass the information around, and then I set the, the Xbox information as well. And now we can actually go ahead and hit play one more time. And there we go, hit play. And we can see the player information from human. So we created a player that had an ID and it had all the information that the human has. So let's actually just do a recap on everything that we did. Is that I actually walk you through, the definition of a class. We talk a lot about what a class meant, what polymorphism is, what inheriting is, and then also I show you how to derive from base classes. I also show you how the class was structured, and we went through different examples of how to create a human, how to create a player that inherits from a human, how to create a monster that inherits from the human, and also was missing some parts of their body. And I also show you what composition was and how we could use a score inside of the player. So that's really everything that I wanted to show you today, guys. I'm gonna get everything checked in right after this video, and feel free to check the GitHub repository for some of the examples that I show you. And if you guys have any other questions or suggestions for new videos, let me know, and don't forget to subscribe and share this video. Thank you, guys.